This is Miss Humbert here, and today we're going to be talking about Unit 2, Notes 3. So we're going to talk about calculating the slope. Now that's something you did in algebra, and we're going to take it and we're going to apply it towards geometry today. Okay, so first of all, we talk about, if you're talking about ski resorts, they're going to rate their trails based on the difficulty level, and they do that based on the slope of the hill, so how steep that hill is. So generally, the easier trails have a slope that ranges from 6% to 25%, where more difficult trails have a slope of greater 40%. So for example, a smaller slope. So a smaller slope is going to be more horizontal. So a smaller slope is going to look more like this. It's going to gradually increase. Whereas a larger slope, you might just want to jot this down just for reference to yourself. A larger slope is going to be much steeper. You think about when you're walking up a hill, you always hate the really steep hills that have a larger slope because it's a lot more work. Now here's the most important part that you needed to do. So slope, we typically say, is rise over run. You'll hear me say that a lot. So we're talking about how much we're going vertically, vertical rise, and then how much we're going horizontally over. So you'll hear me talk about slope as rise over run. Okay? All right, let's take a look at this first kind of talking about the slope. Okay, so what am I doing to get from A to B? So what we're going to do is we're going to go down. I went down -3, and I went over 1, 2, 3, 4, 5, 6. So I went down 3, right 6. Now that's a fraction I can reduce. Both those are divisible by 3, so that's going to be a -1/2. So the slope of that line was a -1/2. So how do I calculate slope? What's the formula for that? Well, let's take a look. Let's make this a little bigger here. Maybe? Please? Okay. So slope, to calculate slope, there's a formula, and that's what I want you to write in that box. So the formula is going to be y2 minus y1 over x2 minus x1. So what does that mean? So you're going to have a point. Your first point is going to have an x1 and a y1. Your second point is going to have an x2 and a y2. Okay, so that's what we're going to use to calculate this out. So let's go ahead and let's take a look at positive slopes. We'll skip over that. Let's go ahead and take a look at these examples instead. Okay, basically positive slopes are always going to have a positive slope. Okay, that makes sense. You're going to have a positive number. Negative slopes are going down. You're going to have a negative slope. So let's take a look at this one, the slope of JK. So first of all, I see that it's going upward, so I'm going to want it to slope upward. So the first thing I want to do is identify the coordinates of each of those points. So for this one, I see that I went left 1. Remember, coordinate points are always x and y, so I went left 1, and then I went down 2. All right. Then for this next one, I see that I'm going over 1, 2, 3 for this point, and up 1, 2, 3 for that point. So now we need to calculate the slope. So what I like to do is, what helps me a lot is to go through and label the points. So let's call this x1, y1, x2, y2. And this is something similar that we did to when we were doing distance formula. So we're going to take y2 minus y1 divided by x2 minus x1. So now we have that set up. So first of all, we have y2, that should be -2. y2 minus y1. -2 minus 3 is going to give me a -5. Over x2 minus x1, -1 minus 3. So you're subtracting two negative numbers. So they're going to get more negative. -1 minus 3 is a -4. The only thing we have left to do now is to simplify the fraction. Well, they're both negative, so I'm going to change them to be plus a positive, and then we have, for that one, 5/4. So that right here is our slope. So if you ask for the slope of that, they would say 5/4. Okay, so let's go ahead and calculate the coordinate points of this next one. So for L, I see that I'm going left 2 from the y-axis. So my x-coordinate is -2. Then I see I'm going up 1, 2, 3. So then my y-coordinate is going to be 3. To calculate out this point, I see that I'm going right 1, which is positive, and then down 3, which is going to be negative. So next what I'm going to do is I'm going to go ahead and label my points x, y. So I have x1, y1, x2, y2. So now I'm going to do this. I'm going to do y2 minus y1 divided by x2 minus x1. Now remember, when you subtract a negative, it's going to become plus a positive. So now we're going to have negative 3 minus 3, which gives me negative 6. 1 plus 2 is 3. Negative 6 divided by 3 is negative 2. So the slope of that line then is negative 2. Okay, let's keep going. So let's take a look at the back side of that paper. So for number 3, we want to calculate the slope between those two lines. We have 1, 2, 3, 4. So we're going left 4, and then we're going down 1, 2, 3, down 3. So that's the coordinate points of point N. So for point P, we're going right 3, and then down 3. So now we want to go ahead and calculate the slope between those two lines. So what I'm noticing is that it's a horizontal line. So my slope can't be too hard, right? Because I'm walking a straight path. Well, let's see what that means in terms of slope. So I'm going to take y2 minus y1, remember minus a negative becomes plus a positive, over x2 minus x1. So then I get 0 divided by negative 6. So if I have 0 things, when I divide them 0 ways, what am I left with? Well, I'm left with 0. So here's what you're going to kind of be working on picking up today. Horizontal lines always have a slope of 0. Okay, we're going to talk more about your horizontal lines and your vertical lines on the next note sheet. But the biggest thing you need to remember is that horizontal lines have a horizontal slope. So let's go ahead and let's take a look at the slope of QR. So Q, we're going over 1, 2, and then we're going up 1. For R, we're going over 2, but then we're going down 4. So those are our 2 points. So now we have a vertical line. Well, that would be a really hard slope to walk up. We'd have to walk straight up. So let's go ahead and let's label our points. So we have x1, y1, x2, y2. So I have y2 minus y1 over x2 minus x1. So I get negative 5 divided by 0. So now I have negative 5 divided by 0. That just really doesn't make any sense. Okay, in mathematics, you cannot divide by 0. That's a no-no. Okay, you cannot divide by 0. Think of it this way. If I had 5 things and I divided it 0 ways, am I really dividing? No. So whenever you have anything that's divided by 0, your answer is going to be undefined. Okay, anything divided by 0, your answer is undefined. Okay, let's take a look at a couple more. So for our next one, find the slope of each line. Lines B and R are parallel. So line B passes those 2 points. Well, let's go ahead and let's calculate the slope between those 2 points. Okay, so y2 minus y1 over x2 minus x1. Well, 2 minus 6 is going to give me a negative 4. Negative 9 divided by negative 3 is going to give me a negative 12. Well, first of all, negative divided by negative is going to become positive. Both of those numbers are divisible by 4, so that fraction can be reduced to 1 over 3. So the slope of line B is 1 over 3. Taking a look at the slope R. So for slope R, we want to calculate between those two. So we have x1, y1, x2, y2. So we have y2 minus y1, cancel, divided by x2 minus x1. Well, 3 minus 4 is negative 1. 2 minus 5 is a negative 3. Again, a negative times a negative is a positive, so we get 1/3. So we know that R and B are parallel. That was given to us. Take a look at their slopes. Ask yourself, what are you noticing about their slopes? Okay, let's take a look at this next one. Now we know that S and P are perpendicular, so we're going to calculate the slope between them. So we have x1, y1, x2, y2. So we have y2 minus y1 over x2 minus x1. Well, negative 6 minus 1 is negative 6. Negative 1 minus 1 is negative 2. Negative 6 divided by negative 2 is a positive 3. So the slope of S is a positive 3. So let's go ahead and we have x1, y1, x2, y2. So we have y2 minus y1 over x2 minus x1. Well, 1 minus 2 is going to be a negative 1. 6 minus 3 is going to give me 3. So then I get a negative 1/3. So now I know that those two lines are perpendicular. What do you notice about their slope? Okay, well, let's take a look at these. So two lines have the same slope if and only if they are parallel. So that's what I wanted you to notice on that previous part. Okay, if they are parallel, then they have the same slope. Two lines are perpendicular if and only if their slopes are. So this is what I hoped you notice about the two other slopes, is that they're flipped. You take the 3 and you flip it over, and then you make it the opposite. So if it's positive, you make it negative. If you negative, you make it positive. And that's called opposite reciprocals. So 3 and negative 1/3 are opposite reciprocals. So if you need to, go ahead and write an example down so you know what an opposite reciprocal looks like. So for example, 3 to negative 1/3 is an opposite reciprocal. Okay, so 3 to negative 1/3 is an opposite reciprocal. So we want to find out if the following lines are parallel, perpendicular, or neither. So we need to calculate the slope of each of those lines. So for the first one, x1, y1, x2, y2. So we have y2 minus y1 over x2 minus x1. So 1 minus a negative 9 is going to become plus. That's a negative 1, sorry. Or a positive 1. Sorry, positive 1. So 1 plus 9 is going to give me 10. 4 minus 7 is going to give me a negative 11th. So now we want to calculate the slope of this one, x1, y1, x2, y2. So then we have negative 4 minus 6 divided by 15 minus 4. Well, negative 4 minus 6 gives me a negative 10. Remember, when they're both negative, it's going to get more negative. 15 minus 4 is 11. So what I noticed, even though this has a negative 11 on the bottom, it's still a negative fraction. So 10 divided by a negative 11 and negative 10 divided by 11 are the same thing. So they're actually both the same slope. So both of these lines are parallel to each other. So that concludes your note video today. So go ahead and show me your completed note sheet when you're done, and I will give you the homework. Thanks for listening.